Welcome to the Copernicus Data Space Ecosystem webinar with a focus on Sentinel data for water sports. In this webinar, András Zlinszky will explore how the available Sentinel data can be utilized by water sports enthusiasts and professionals alike, offering insights into conditions relevant for activities such as sailing, surfing, and kayaking. I have to say that András is not a marine navigation expert, so if he says something incorrect during the webinar, please feel free to note it in the comments and we will happily feature you in the Q&A session. Also, we would very much welcome contributors to a next edition of this webinar. So if you are interested, just let us know. So without further ado, András, the floor is yours.
Hello everybody, welcome to Copernicus Data Space Ecosystem and this webinar. A few words about myself before we start. I'm actually a lake biologist, a limnologist by training, and I work as the community evangelist, the communication guy for Copernicus Data Space Ecosystem. I used to be quite a bit into dinghy sailing on Lake Balaton in Hungary, my sort of home grounds, and now I do a lot of kayak touring, so I like to be on the water, just like most of you. We might have some technical difficulties with today's webinar because I see that it's slightly slower than usual. But anyway, let's start and I hope everything will be okay. So what I want to show you here is Copernicus Browser. This is the online interface for exploring satellite imagery. If you just go to browser.dataspace.copernicus.eu, then what loads is this map with a date selector and some data layers. Let me show you my favorite place. This is Lake Balaton in Hungary. So this is where we like to go for our holidays and our water sports. If you just zoom into a place, or you can also search it in the search box and click show latest date, it's going to pull up the latest image and you can already see quite a few things. Here we have a selection of different satellites. We are going to explore Sentinel-1 and Sentinel-2. For now, I will tell you about the differences between these. So what do we see on this very latest image of the lake? Well, we see some shallow parts, right? And we will also explore a bit more quantitative bathymetry applications in this webinar. We see a stripe here where a motorboat went through because the lake is relatively shallow. Actually, we even see the boat. And at a larger scale, we see some wind and current patterns, sort of as the sediment is mixed up by the wind. Now let me give you a sort of a more defined example. If we go back to this image, this is the 6th of June 2023. So actually, this is the starting date of one of the most popular sailing races in Europe, the Kékszalag Blue Ribbon race. It starts from over here. What you see, these little specks are all sailing boats traveling through the water. So most of the fleet is over here, battling it out along the North Shore. They will have a marked round up here. And the fastest boats, the big catamarans, are going downwind already in this leg. And you can see the chase boats and you can see the boats themselves. The sailing ones are easy to recognize because the sails have a large shadow. So, I mean, when I was starting with yacht racing, what my coach would always tell me is you arrive a couple of hours before a race to the venue, and then you sail into the track to explore what the wind looks like, to explore the local conditions. Or if you are arriving to an important race like a world championship or something, then you usually travel there a couple of days earlier to sail around and to get a bit of a hang for the local conditions. And this is the main thing that Copernicus Data Space Ecosystem and satellite data can help you with. I mean, you can't spend 2 months at the venue of a race, but you can easily check the last 2 months to see what typical wind conditions and typical wind patterns exist around a specific venue. So let me give you an example. Now we are changing from Sentinel-2, so from true color imagery to Sentinel-1 radar. And satellite radar is a special thing. We are emitting a radio signal from the satellite, just like we do from terrestrial radar, from the radar that might be on the ship. And we are looking at objects that interact with the returning electromagnetic radiation. Now, this radar has a wavelength of about 10 centimeters. So whatever is approximately in the 10 centimeter range will interact with it. It will reflect it stronger. And this is how water surface roughness works. So we go to the VV decibel gamma parameter. And what you see here is the actual wind pattern over the lake. So these are the water surface roughness patterns. You see some wind shadows over here, for example, in the lee of this pier or in this bay. You also see the prevailing wind direction, which is sort of southwest. Here again, you see a wind pattern, a wind shadow behind this peninsula. And these patterns allow you to have a basic overview of what the local conditions look like. Again, we can check how the wind is different between one shore of the lake and the other, or one end of the lake and the other. These images, so you see that here's a big gap in wind in this bay and also in the north and south shore of the Keszthely Bay. And if you're interested in longer term changes, then you can just open up the calendar panel and pull up the images from earlier dates. So this is very roughly how true color images and water surface roughness images work in Copernicus data space ecosystem. Now let me bring you to a different place, sort of a more safety-ish application. This here is a place just south of the Isle of Wight. Maybe some of you will know it. We are in the UK. It's called St. Catherine's Race, not because it's a sailing race, but because it's a part of the shore where the water moves very fast and very intensively. So on normal navigation charts, this area is marked until about up to 3 nautical miles away from the shore as an area of very rough seas, which you would probably want to avoid if you can do so. Why is this? Well, because the currents traveling along the island, they often meet with the winds, and this creates very intensive wave conditions, and also because there's a sandbar under the water here, which raises the seafloor and creates these waves. So this is a relatively low wind day out on the Isle of Wight, but you already see this sort of mixture pattern, right? The transparent water mixing up with the more murky water. You see this mixing front, so you can see that something is going on in this area. Now let's check a space with slightly different wind conditions. Here we go. This is a different date. This is in July 2022. And so the white spots here are not clouds. They are just the crests of waves. They are sun glint patterns. So water reflecting off the edge of the waves, light reflecting off the edge of the waves directly into the satellite. And you see sort of the typical pattern and the wind streaks along the coast. But over here, you see that something intensive is going on. And again, this is not a particularly stormy day, but the waves over here are relatively large. And the image allows you to sort of outline this area to have a guess of when and where these conditions occur. Let me show you another case in really stormy conditions. So this is what a windy day looks like from above. You can see some streaks, the current moving through the water. You also see actually very intensive wave action of this spit, where again, water traveling in different directions meets. It creates whirlpools, it creates up and down wellings, and these will also influence the local surface conditions, the local waves. But down here in St. Catherine's Race, you really see some major waves, some large breakers, which are forming, and they don't exactly follow the swell direction. These are sort of local things which make the sea very choppy. How can you explore this in further detail? Well, the tool I can recommend is the time-lapse feature in Copernicus Browser. So if you just click on this little film and the play button, it is collecting all the images from a period of time that you can set, right? I'm pulling up the minimum tile coverage to make sure I'm only using images that actually cover the full area. I'm keeping the cloud coverage as it is. And now if I click search, it's querying the images from our archive over this area that correspond to the criteria that I have set. And then if I play the time lapse, you will see how the conditions change throughout the days. Of course, if you want to do some more detailed research, you probably want a longer time series. But this is how this little tool works for exploring conditions throughout time over a very small area. Now, the other tool, of course, you need is the wind direction or the wind conditions. Let me show you a very, very cheap and easy weather archive. Probably other weather archives exist, but I haven't really been able to find one that's free and available across the globe. So this is timeanddate.com, a very, very basic weather site, right? It's actually more like a world clock, but it also includes weather archive. So if you select the place, I've selected Cowes here, which is just the northern side of the Isle of Wight, and you select the month, then you can go back to the date, which corresponds to your satellite image. Right now, this windy day is the 2nd of April. So we go back to the 2nd of April just to check the wind direction. And what we see is that we have a really quite strong easterly, northeasterly wind blowing along the coast. The wavefront, the swell that we see sort of corresponds to this, but also we clearly can identify this very, very rough, very choppy patch of water. Now let's check this out again using water surface roughness using Sentinel-1 data. So this is a more general map of the English Channel for the 1st of January, a really stormy day. And there are some features that I want to highlight for you. Well, one is this sort of mixing front between a wind pattern that's dominated by the southern shore, by the Dutch and French shore, sort of wind moving in from there. And the other is the presence of these streaks. Again, you have the wind shadow along the shore. But these streaks are a very, very characteristic feature of water moved by wind. So as water is pushed by the wind, it actually creates a rotating motion like spirals or cogwheels. And as the water is moving up, the surface is becoming flatter. And as it's moving down, the surface is becoming rougher as the waves converge. These are called Langmuir cells. You can probably observe them actually on the water as you are sailing. Again, these are these lines of very flat water which are pointing exactly in the direction of the local wind. But you can also observe them at this scale. So when the wind is influenced by the coast, these streaks, these Langmuir streaks, can also show the local pattern of the wind. And let me show you another like really seriously stormy day. This here is storm Eowyn. You might remember it created some major damage in the UK. I'm scrolling out a bit to show you first the place where we were. So this is the English Channel. Again, we see the wind shadow effects. But as the wind sort of comes in from the north and gets stronger on this image as we move towards the north, you see some other patterns. These are local sort of inversion waves. On the water, you perceive these as periods of stronger and weaker wind as you tack upwind, or as you move through the sea. This is what they look like. So you can actually identify the places where these are sort of characteristic if you look at an overview of images. And if I go up here to the Balearic Islands, these round patterns are, well, in sailing we call these cat's paws, right? Gusts of water which sort of spread in a fan shape. Again, if you're on the water, you're probably familiar with these, you know how they happen, but they also occur at the scale of several tens of kilometers, right? This is 26 kilometers, a very, very strong wind gust, or probably a bit of a vortex traveling across the surface of the sea during storm Eowyn. This is again a process that creates the periodicity, the gustiness of the wind. So you can watch water surface roughness at this level of detail. So why is this useful? Well, when you are working in offshore navigation, you typically download a weather file, a GRIB file, every 4 or 5 hours or every 3 hours from a server such as EUMETSAT. These will have a resolution of 3 to 5 kilometers if you're lucky. Now these data sets, of course, they have a resolution all the way down to 10 meters. So if you can do your homework before your race, or if you plan your navigation, you can check out the local wind patterns, the detail within the big pattern which is given to you by the GRIB, and that probably helps you navigate more accurately. Let's move on to another example again. I'm moving to the Balearic Islands in the Mediterranean. So here we are looking again into Sentinel-1 data over a specific date, the 11th of November. What do we see? Wind coming in from the northwest. We see a couple of shore effects. We see some wind shadows. We see the wind shadow of the island as well. And then here, sort of the convergence zone, the gustiness or the vortices created in the lee of the island. But why do we see this X shape? Well, we see this because over this region, we have two overpasses of Sentinel-1 data, one after the other, one in the morning and one in the afternoon. So if we change the mosaicing order of the image through this calendar panel from most recent to least recent, the other one comes up. So this is actually the morning wind around 10 o'clock. And this is more like 2 o'clock. And you can see that the wind pattern has dramatically changed. And we have a very strong border between different wind systems and the large gap here, which you don't want to sail into. So again, these data sets can really illustrate the heterogeneity of the wind field and also typical patterns of gusts or local winds. Let me give you another example. Is it the same place? Yeah. If we go to Corsica, I don't know how much you have heard about katabatic winds. These are again a feature around the shore or around the islands. What happens is warm air rising up over the sea, cold air going down over the island, and converging in the valleys. So we are in November now, late autumn. The Mediterranean Sea is warmer than the land. And so as the warm air rises above the sea and descends above the land, you get these local winds which blow out from the valleys. And again, you see the wind direction here is completely different, the opposite actually from here. And if you know these patterns, you can probably sail around the island using the local winds. This is a super calm day, so there is no like major large-scale swell pattern. This is a very, very calm autumn day when the katabatic wind rules the wind patterns. And you can explore, based on the satellite image, based on the Sentinel-1 water surface roughness, where the windy and where the calm areas are. So what you typically do if you want to learn about exploring wind patterns or water patterns in general with satellite imagery is you find a place which you are familiar with, the place you regularly go to, and every time you go out sailing or surfing, you go back and check the last satellite image. And then you compare it with what you've observed on the water, where it was more windy, where it was calmer, and you start developing a feel for interpreting the data. Now let's move to a different application. Let's move over to bathymetry. This browser can also take custom visualization tools. So, I mean, what you see here is just Sentinel-2 true color imagery. But we can select different ways to work with the data, different ways to visualize it. And ultimately, here we can also edit the code which is used for visualization. And we have a repository of different code collections for various applications. And one of them is called satellite-derived bathymetry mapping. This is a script where the actual depth of the water is evaluated from the ratio of the red and blue channels in the image. And then it's fed to a palette, which allows you to get some sort of an understanding of the local water depth. This is not perfectly accurate, of course. But I mean, when you are preparing for a trip or preparing for a race, you are trying to collect information from different sources and compare them to evaluate what's true, what's false, what you can live with, what you can base your navigation on. And then this is going to be one source of information. This is Kingman's Reef in the Pacific. So it's a small reef of about 11 kilometers across. It's a very remote place. It's uninhabited, but of course it's a sanctuary for marine wildlife. You might want to visit it. You might want to snorkel around it, but the maps that are available are not particularly good. So this is the best map I could find from Kingman's Reef. NOAA map from the late 1990s. So this map gives you water depths in fathoms, right? This is the depth. But looking at a paper map like this, or even if you can georeference it somehow, this is not something that you can directly take and use on your ship navigation. And of course, the uncertainty of what's between these points will always be there. So what you know is you have this channel where the shallowest point is somewhere around 9 or 10 fathoms. You can check how this matches your ship. And then if you go back to the browser, you can try plotting out a line to go into the lagoon from the outside. Where's the deepest part? Well, from the true color image, we infer that it's probably over here. We can try and apply this script here. The way it works is you copy the script from here into this window. I have this prepared so I can show it directly, hopefully. Yes, just wait a second for it to load, right? So now this is a water depth visualization. It's not exactly quantitative because the colors are not directly representing individual depth measurements, but it's actually possible to calibrate it. If you check out the documentation of this script, it's possible to take measurements or points from places where you know the depth and actually feed back that information to the script. But what you already see is that this is the depth map of the area. And then you're mostly interested in this part. You can use this line of interest tool to plot out a way through the reef into the lagoon. And once you have this, you can copy it to the clipboard, you copy it to a text file. And then this is a file that you have to save as a JSON. Just saving it off screen. So you have to select the GeoJSON format. Like this. And now there are online sites where you can actually upload a GeoJSON and you get back a GPX file. So a file that you can directly upload to your navigation device. Hold on a sec. Yes, it's this. So quickmaptools.com, GeoJSON to GPX. And now here I upload the GeoJSON. Maybe I can't wait for it to upload, but once it's there, yes, you can convert to GPX. And then when you receive that file, this GPX, this is a file that you can directly upload to your ship's navigation GPS, and you will be able to follow that track through the reef. Once again, the accuracy of this is not perfect, but this may be the sort of spatially most detailed data source that you can find. It will certainly help you find a way through areas which are not perfectly charted. Let's move on to surfing. Exploring new surfing spots is quite a hype on the internet. It still is. So some people search Google Earth, some people search other satellite imagery to find the perfect wave, to find the new spot that nobody knows where it's extremely exciting to go on the waves. The site for this year's Olympic Games was also explored somehow like this. So satellite imagery definitely plays a role. Let me tell you what you want to look for. This is an example of a place called Klitmølla in northwestern Denmark. It is also called Hawaii because it has recently become very, very popular with surfers, but it's still quite cold, right? Why is this? Because you have a very consistent northwestern swell coming from the sea. So these waves are more or less always there. And here you have a stretch of shore, which is at an angle to the incoming waves. If it's perpendicular, the waves you can surf are relatively short because it comes in and then it breaks. But over here, you have a breaking wave traveling for a long, long, long time along the shore at an angle. And this means that you can surf the wave as it breaks and you can travel a long distance. And you're actually also not very far from the shore all the way, so it's quite safe. These are some of the patterns that you want to explore if you're looking into finding a new surfing spot. So consistent swell and the wave that travels along the coast in some way. There are different kinds of waves, and as much as I could read into this, there's a lot of dispute over what the perfect wave looks like and where to find it. But one highly popular place and one highly popular type of wave is called the A-frame. So you either have a right-facing wave or a left-facing wave, and the A-frame is a wave with a peak that you can surf sort of on both sides, standing both left and right. And the way you find these is where you have a headland sort of facing into the swell, and you have a very consistent wave pattern That's where you can get a wave frame. This is Panangalat Island in Indonesia, a place very famous for these so-called A-frame waves. It has several surfing resorts around it. Let's take a bit of a broader look into what makes this place so special. So here you see this consistent swell pattern, again coming from the southwest. You see the refraction of the waves as they turn around the main island, right? They sort of hug it from the north and south. And then here you have a flat reef, close to the island, and you have the triangle-shaped breaking of the surf. So this is the place where the swell comes in from the south as it circles the island. And here on this sort of reef peak, it's going to break into a perfect A-frame. So let me give you another example of this place under slightly different weather conditions. Again, we have a bit of a different wave pattern, see, because the swell is now coming from the southeast. Again, it's slightly refracted as it curves around the island. It creates this crisscross pattern with the waves reflected off the island. And here you have this reef peak, which is creating the very, very popular waves because it's so pointed, and that's why the waves form this peak where you can surf off both sides. So these are some of the patterns that you want to look for if you're trying to scout a new place for surfing. And again, compared to other platforms where you can look into high-resolution satellite imagery or aerial photos that have higher spatial resolution, this has high temporal resolution. So if you take a look, you see you have a satellite image more or less every 5 days. And so this means that you can really look back, you can check the archive and explore how the waves behave under these conditions or that conditions, depending on what you prefer. So this is how to scout a surfing site using Sentinel imagery. Now, let's move back to my home country and my home sport. I want to show you how to explore a place for kayaking. So kayaking is, well, some people kayak on the ocean, of course, but I kayak on rivers. And one of the exciting times to kayak on a river is, of course, when it's flooded, because then you can go into the floodplain, you can explore the forest, you can move from one oxbow to the other. And this is a place in northeastern Hungary called Bodrogzug. We have this main river, the Tisza, and we have this small tributary entering the river coming from the north. And over here, there's this large floodplain. And every year, there's a flood that occurs in this area. And then for a week or so, this place turns into a wonderland, which is really exciting to explore by kayak. What you see is actually the very same visualization that we use for water surface roughness. So water areas are very dark black. And over here, you see that these wetlands are also highlighted in black. Let me show you for a moment the true color image, right? So this is a plain with all these oxbows and remnants of small lakes. And then time to time, the rivers come together and cover it. So how do I find the right time for exploring this by kayak? Again, I use the time-lapse feature, right? Here. And now I know that my flood is probably in the spring months. So what I do is I filter by months. I'm only interested in March to May, but I want to look at several years. So let's go back to maybe 2020. And then if I run a search, again, since this is radar imagery, I have to up the tile coverage. Since this is radar imagery, it's consistent. There are no clouds because the radar sees through clouds. Again, those who operate the radar on a ship will know this. And so now I'm collecting, well, I'm up to 45 images now and still counting, going back to 4 years. Okay, so it's 110 images over a period of 4 years. Let me ramp up the visualization speed a bit. And now we play the time lapse. So when the area is black, then it's flooded. That's the exciting part. So in 2021, again, it's early March to April. In 2022, it's sort of late April-ish. In 23, it's late March. And in 24, it's also sort of late March to early April. So this time lapse tells me when is the right time to actually visit this place if I want to catch this amazing situation with floods and the possibility to kayak into the meadows. I don't have to get up from my chair. I don't have to go there and risk not being there at the right time because the satellite imagery tells me when the right time is. Okay, Finally, one more application. Here we need to talk about water quality. Of course, water pollution is a big issue. And for many of us, the waters that we can reach are threatened by water pollution and often threatened by algae blooms. So if a water body, a lake or a river or a coastal sea receives too much agricultural runoff or too much sewage, then the algae, the small microscopic plants in the water, start growing very fast. And this creates ugly conditions. The water turns green and smelly. And of course, it can also be hazardous for human health beyond a certain level of chlorophyll or pollution. So what we see here is IJsselmeer and Markermeer in the Netherlands. These are two large inland artificial lakes, which are very popular for water sports, for holiday activities. So in this image, which is the latest image from the 30th of June, you can instantly see that the water is sort of abnormally green. It shouldn't be green like this. It should be blue or black, just like these lakes. But how do you actually convert this to water quality measures? You have to change the data collection. You have to go to Copernicus Land Monitoring Service. This is a collection of data products which are calibrated downstream products from specific regular mapping campaigns. And here under water bodies, we have lake water quality. And then if I just load the latest image, oops, no, it's the wrong collection. I need this one. If I load the latest image, the top layer is chlorophyll mean, right? So this is the greenness of water, the amount of algae in the water. This is actually telling me how safe it is or how polluted it is to go and swim or surf or kayak over these waters. As you see, this has 300 meters resolution. It's a 10 daily product. So it might not actually be the latest data set, but it's relatively regularly updated, and it's also calibrated. So this is really a standard ready, robust calculation. There's also a way to check the latest satellite image. If you go to collections, configurations, and under oceans and water bodies, you hit again, show latest date. We have a layer called the Ulysses Water Quality Viewer. Now this is a small visualization script that uses the latest Sentinel to image, and it colors the water according to a palette based on the water quality, based on the pollution hazards. So this way, it's possible to check out the water quality, to check out the riskiness of a certain place. It's not 100% perfect because the sediments and the transparency of the water will influence what you see, but it's a nice source of information. So as said, you always want to compare different sources of information. You want to evaluate one against the other, but satellite imagery can be one way to explore the water before you head out or to revisit your memories after you've been back. And Copernicus Browser brings you to this imagery for free. Thank you for following.
Thank you, András, for this really great presentation. Let me check if we have any questions.
Most important question we often get, and I didn't point this out in the beginning, is this free? Yes, this is free. This is completely free to use for any purpose, for industry purposes, for exploration, whatever. The only thing is it's not a certified source of navigation information, so always take care and follow common sense.
One question to the Cibel gamma visualization. Could you one more time shortly just describe the difference between shadow and lights if you see something on, for example, Baltic Sea? Because if I understood correctly, that the lights means the wind, some difference because of wind, or what exactly is the difference between the shadows? I'm talking about the Cibel gamma.
Yes, here's an example of the Cibel gamma. So actually the white areas, the strongly reflecting parts, are where the waves, or actually the wavelets on the top of the large waves, are in the range of 10 to 30 centimeters. So the range where the radar signal is reflected strongly. You can get larger waves without these wavelets, and then they will reflect a bit weaker. And you can also get very flat water with no wavelets, which is also going to reflect weaker. Both of them are going to be dark. So you need a bit of local knowledge. In this specific case, I know that for moderate winds, the wavelength or the wavelet length on Lake Balaton is typically around 10 to 30 centimeters. So I can easily infer that this is a windy place and this is going to be a shadowy place, or this is going to be a calm place. If the wind is a lot stronger, or if you're on the ocean, then it's a bit more complicated. Then it's more like inferring the generic pattern. So we go back to storm Eowyn. Here, obviously, the white areas are, again, wavelets of approximately 10 centimeters on top of the large waves. If you zoom in further, let's just wait for this to load, then you see the actual wavefront of the swell as well. So see, you see some strips in the northwest southeast direction. This is the main direction of the swell, and the local winds, the gusts or the upwellings, are influencing the wavelets. So that's why you see some bright and some dark patches. So it's not immediately trivial to interpret this. Unfortunately, we can't directly connect it to, for example, wind speed. What we can do is read the generic direction of the wind, read the gustiness, read the patterns from the Sentinel-1 image.
Okay, thank you.
Let us wait maybe a couple of more seconds if anybody else collects the courage to ask anything else. Well, in that case, you're welcome to use our Copernicus Data Space Ecosystem Forum for further questions. The recording will be published on our YouTube channel in the next days. I invite you to stay tuned and follow our social media for future webinars. Thank you, András, for your presentation, and to all of you for joining us today. See you the next time.
See you. I wish you a wonderful summer. Goodbye.